In this short video, I'll be taking you through how to approach any paper 4 alternative to coursework questions from the Cambridge IGCSE geography paper that looks at river investigations. Now, I could have gone through past questions, but really, when you look at past questions and you put them together and you look at common questions that appear and you look at the mark schemes, really, this video is to draw out the common language and useful points and to help you approach each type of questions. This also is a really good video to help you with useful language and points to consider if you're writing coursework. As I go through how you can use the methods to collect data and common issues associated with them, how you can improve their reliability. But really with this video, it's impossible to cover every aspect. Every question asked in this paper is slightly different than a previous topic. If it's like on coast one year, it'll be a slightly different focus on coast from previous year. So really, this is just general points. So it's up to you to practice, to use this guidance in the videos to help you. But really, you need to go through previous questions. So this video is split into several different chapters, each chapter looking at each part of the coursework mark scheme, so the introduction, data collection, data presentation, data analysis, evaluation, conclusion. Now remember, you won't get an even split between those. Each of those is worth 12 marks. You won't get an even split between those in every single paper. Some exam papers focus maybe on data presentation or data collection, or you exploring the hypothesis, whether or not you've proved or disproved this. So that's why I've structured it in this way. So when you are using past papers, you can look at the chapters and you can go back and review the various points to help you explore this. Now, I will say with paper 4 alternative to coursework, really, the introduction draws on knowledge and skills learnt from paper 1 and 2. So as long as you revise really well for paper 1 and 2, the introduction questions shouldn't be too difficult. Data presentation is really straightforward, as that tends to be looking at completing graphs. Data analysis is you looking at the data, deciding if you proved or disproved. But really, data collection and evaluation are the ones that is probably the knowledge that is specific to this paper. You have to know how to collect certain data. So, for example, in the case of rivers, how you look at velocity in a river, the width and depth, water pollution, and you also need to be aware of common reliability issues. So that's what this video is looking at. So really, that's why I split it in data collection into the various methods, and I've tried to find questions that get you to think about how you can sort of look at the reliability of these methods. Now, like I said, I've looked at every paper going back to 2016, so I might have missed something out. So this video really gives you an overview of each of those methods. Again, it requires you to practice. Now, I'm not just doing this for rivers, I'm doing this for a whole host of other videos. So if you do like that, please do subscribe if you think it'd be useful for you. So, introduction style questions. So, hypotheses. As you know, with this paper, it's all about a student has come up with 2 hypotheses, and you will have questions about those. These are the most common ones that occur within rivers. You can see here I've provided you a selection of some of the hypotheses that have occurred in various past papers. And so usually a hypothesis for a river investigation will do one of the following. State how something will change along the river or over time. So something like velocity or pollution levels will increase or decrease with distance downstream. Or will increase or decrease between this year and the next year. It might also ask you to compare 2 factors to find the relationship. So as one increases, what should the other do? So if the velocity of the river increases, what could the width of the river do? You might also compare 2 factors to see which one is greater. An example for the infiltration rates. So the rate of infiltration is greater on the steeper sloping lands. And so when you do construct a hypothesis, you expect it to be true. If they are false, it is the opposite. So for example, there is no relationship. This feature hasn't increased with distance downstream. And so stating how something will change along the river is probably the most common hypothesis that will be used in this exam. Most of that hypothesis is based on what we call the Bradshaw model. And the Bradshaw model shows how certain characteristics of the river will change as the river flows from its source to its mouth. Now, these particular characteristics should increase from the source to the mouth. They are the width and depth of the river. As more water is added through tributaries, and things like that, then there should be greater erosion taking place because the river has more energy. Therefore, if the width and depth increases, therefore the cross-sectional area of the river should also increase. The velocity. As more water is added and there's greater erosion, the channel becomes smoother, friction slows down, the velocity of the river should increase. And so if the cross-section increases and you times that with velocity, then therefore you've got the discharge, the amount of water flowing through a particular point. So all of these should increase with distance downstream. And of course the wetted perimeter. The following should decrease with distance downstream. Sediment size, with more water, it's more erosion, sediment becomes smaller. Sediment shape, more water, more erosion, sediment becomes rounder and smoother. The gradients, as there's more vertical erosion, and eventually the river will flatten out, therefore the gradient will decrease. And so these are the types of questions that you could ask that require you to have knowledge of the key terms and theories associated with river investigations. So for example here, simple definitions. And then again, linking key term of this particular part, river begins at its source. Here, looking at how the various characteristics should increase or decrease with distance downstream. And so again, here you can see I put the mark schemes in to show the various bits and bobs that you should include. As well, there are some nice questions here. This is for 3 marks. Describe possible changes in the features of the river and its valley downstream. I've always found this table to be quite helpful. So the Bradshaw model, these are the characteristics of the river that should increase. These are the ones that should decrease. In terms of other features of the river, landforms, these are how the landforms that tend to appear or start to appear at the various courses of the river. And this is what the valley and channel should be doing and processes that occur. So I think this table is really useful when looking at the river characteristics, and you can link this to case studies of paper 1 and paper 2. And so because you've got so many different characteristics, and if you think about it, it's actually really easy to write an answer to this. So here, the river channel should get wider and deeper with distance downstream and start to meander. The river will be at its steepest in the upper course of the river. And look at all those various points that you can include for 3 marks. Again, it requires you to think about why sediment should become rounder or why the discharge should change. And so again here, I've put some various comments here based on the mark scheme for you. So again, look at your notes, include them into your revision, look back at paper 1, paper 2, and have a clear understanding of why river characteristics change with distance downstream. Other questions that do appear, you've got things like water pollution that you might not necessarily need to be aware of in depth for paper 1 and paper 2, but you are expected to know it for this. So again here, think about what could cause pollution. Fertilizers from farm could run off into the river, industrial waste from factories. So think about it that if you're unsure. And again, I'll give you some points here. Why would tourists affect infiltration rates? Well, infiltration is about water going into the soil. Loads of tourists, they could flatten the soil, harden it, make it more impermeable. So again, here's some various points like that. So if there's anything you're unsure about that you might not have studied with paper 1 or paper 2 in huge amounts of detail, think about it, apply it to other situations. Data collection questions. Like I said at the start, these questions are perhaps the ones that are specific to the alternative to question paper. And these are the ones that often are the most technical in terms of the language you need to know, and perhaps the hardest to learn because there are, for some methods, very specific equipment that you need to use, and you have to carry it out in particular order. So this video, please do use the chapters to go through each particular method if you are revising and you want to know how to approach that. If you are using this for writing your coursework, again, the language in the mark scheme might be really useful to help you write in a very concise and focused way. So I've broken down into these various points. We're going to be looking at sampling, types of data, why we do a pilot study, common risks associated with investigation, and various methods that you need to describe. So again, use the chapters to wind forward or back accordingly. And so again, types of data, really for investigations, there are 2 types. You've got primary and secondary. Primary is anything that you go out and collect. Secondary is data that's been collected by somebody else. And so you need to be aware of the strengths and weaknesses of each one. So again, I've tried to summarize this for you in a table. So again, pause the video, make some notes, or add these points to your notes. Now, when it comes to a river, sampling is really important. It is impossible for you to, rivers can be thousands of kilometers long, hundreds of kilometers long. It is impossible for you as a student to actually go about and look at every single point along the river. That's why we do sampling. Sampling is ensuring that you have enough sites to allow you to make a conclusion. You can have too few, you can also have too many, which makes it impossible to do, so you need to get a balance right, and that's when sampling techniques come into play. So these are the things we need to consider for a river. So, systematic sampling. This is where observations are taken at regular intervals, e.g. we ask the fifth person or we carry out an investigation every kilometre. So for example here, I'm asking the fifth person. Nice and straightforward. Random sampling, on the other hand, is when as every point has an equal chance of being selected. So there's no fixed amounts, you just ask whoever, or you just choose random locations to do the investigation. We've got stratified sampling, where we sort of group data, we look at key aspects of the river, so for example, upper, middle, and lower, and then we choose a number of sites within each one. You can combine, so we've got stratified random sampling, where we group people, and then we randomly select. Or we have stratified systematic sampling, where we sort of group the people and then we choose the third person from each group. So some things to consider about sampling techniques when it comes to river investigations. Obviously, the larger the sample sizes, the more accurate representation of the whole. But sample size do need to take into account the time. So are you doing it over a week or a day? How much? Do you feel like you can actually do this? Do you have the amount of resources behind you to enable you to do this? Big enough group? And also you need to avoid bias. If you focus on one part of the river, that's obviously not reflective of the whole river. So again, you need to consider this. So how do you go about selecting a representative sample for a river? If we were to use random, really it wouldn't work because you might miss out on a huge part of the river. And also you would have accessibility issues, safety issues. You could randomly select those sites and they might actually be really dangerous to go to. And again, the river might be massive and you might only select a small part of that river, yet there might be huge changes along the course of the river. So perhaps random might not be a great shout. We can also do stratified sampling. So like I said, the river is divided up into the upper, middle, lower course. So here we go, and then we could select a site from each one. There we go. Now in reality, this might not work. There might be too few sites. 3 is not enough for a long river. Again, are those sites accessible? Is it safe to get there? Does it take into account the length of the river and the depth of the water for those particular sites? So again, these are the factors that we need to consider when using stratified. We could do systematic sampling. So 9 sites every 1 kilometre. Here we go. But again, similar points as before. In reality, this might not work due to the accessibility of those sites. Are they dangerous to work in? Does that take into account the whole length of the river? So if you were going to do a river investigation, you might sort of do something like stratified systematic sampling. So we've got 3 sites every 1 kilometre within those particular courses of the river. But again, when you're selecting your sites, you do need to be aware of, are those sites easily accessible and safe to work in? And are they representative of the length of the river? So yes, you might not be able to select a site every 1 kilometre, but you would try to as much as possible. Yet in your evaluation, you recognise that you weren't able to do 1 every kilometre because of the issues involved at those sites. Too dangerous, water too deep, etc. So, similar questions that might be asked in terms of this. And this is kind of tied in a little bit of risk assessment, so I'm going to be repeating myself a little bit. It's just 3 factors the students should consider in choosing their fieldwork sites. So again, is it safe, the weather conditions before and during, hazards, human influences, all these various factors like that. Okay, and I've sort of summarised them nicely into this question, summarised the key things to consider in the mark scheme. So do include these into your notes. So another aspect of before you go about doing investigation is identifying the risks. Now you as students might not play a huge part in this. This is mainly down to your teachers, the people organising the trip, but you do need to be aware of risks and how you can manage them in this paper and when you go about collecting the data. So these are some of the common ones that are associated with rivers. Is it too hot, too cold? Bear in mind the river changes. If you're going towards the mouth of the river, is the river tidal like the Thames? Could you slip? If you drank the water or you fall in, accidentally consume some of the water, could you get ill? The time of day, would you do this at night or during the day? Could you get lost? And is it safe to access? So these are all the various things that you could do. And actually, a lot of this is common sense. So let's look at some common risk assessment questions. First one, Complete the table by suggesting different ways to reduce 3 possible risks. You can see the possible risks. How do you go about reducing the risk of slipping? Perhaps you wear sensible shoes. Getting disease or illness from the river water. Avoid drinking the water. Falling into the river and getting injured. You might again wear sensible shoes, check the depth of the water, things like that. Mark scheme. Okay, work in groups, avoid slippery or steep slopes, things like that. So nice common points here. Again, you can see there's some common parallels between different exam papers. Precautions to protect students and things like that. So insects or animals in the river, protection such as gloves, long sleeve, long trousers, insect repellent. So again, a lot of this is common sense. Other questions that are associated with data collection is, why do we go about doing a pilot study? Now, a pilot study is an investigation that's carried out before you do the main data collections. So why would you do that? Really, you do this to answer several questions. Can a full-scale study take place? Are all the sites safe and accessible? Do you require additional costs and resources? As well, it helps people to familiarise themselves with the method, so when they're out and about, they know exactly what they need to do. So it makes it more efficient on the day of data collection. So here are some questions for you to consider. Explain what a pilot study is and give one reason for doing a pilot study. So again, here, this is the definition, and these are the various reasons why people do it. So again, include these into your notes, please. Some other examples: identify 2 advantages of doing a pilot study. So again, learn how to use the equipment and practice fieldwork techniques. Here they are. So please do pause this video, rewind, add these reasons into why we do a pilot study. And it's not just for rivers. Pretty much you can apply this to any investigation that could be asked in this paper. So, data collection methods. This section is split into really 2 parts. Describe how you collect data I'm going to describe how you collect data for the different investigations and with the required equipment, and then I'm going to look at the various strengths and weaknesses associated with each method and how we can go about making it more reliable. The way I've done this, I've split this up into mini chapters, so you can look at each individual method. I've looked at various past questions and I've pulled out common phrases that are associated with the mark scheme. So if you are struggling, you can also use those common phrases and you should get at least 1 or 2 marks, but also it shows you how you can apply this video to loads of different past questions that ask you about how we can collect data for these methods. So the methods that you need to know for rivers. If you're looking at how a river changes the distance downstream, drawing heavily on the Bradshaw model, you need to be able to tell the examiner how you can carry out the width and depth, and with that the cross-sectional area, the velocity, and with that the discharge, the wetted perimeter, sediment size and shape, and the gradient. Now with other methods, you might be expected to know water pollution, calculate oxygen levels, infiltration rates. And so it's really hard for me to go through each method because there's only been, for example, for water pollution and oxygen levels, 1 exam question, so I've used that heavily. Typically, if you're unaware, if you've never studied it, they'll give you a lot of help. So there might be a figure that tells you how to go about doing it, and so you have to apply that knowledge, but we'll go through it now. So, equipment needed for a river investigation. Here we go. Got some ranging poles, tape measure, a ruler, flowmeter, a floating object, clinometer, clipboard pen and recording sheets, a quadrant, stopwatch, and calipers. Other common equipment required: a biotic index for water pollution, a power scale of roundness, and this is the diagram I pulled out from investigation, looking at how we measure infiltration rates. So these are all the various things that you need to be aware of. So what are the equipment used for? Just to summarise: ranging poles, marking out the size and distances, tape measures for working out distances, etc., etc. So please do pause this video, read through it just to be aware of what they do. I will go through them a lot more when we go through the video. I always go through each individual method. So please, if you know how to do one, just recap, make sure your notes are required. You've got the mark scheme, you can be incorporated into your notes. If not, please do get a past paper out in front of you and have a go yourself, or with some diagrams, have a go at trying to answer a question, and then use the mark scheme to use the video to help you ensure that it is the perfect answer. So just to outline what a describing a method question is. Question usually is 4 marks, 5 marks if you need to write a hypothesis. For all these questions, you have to include the equipment that you would use and describe how you or a group of students will collect the data. You could also be asked to draw a diagram, so it's important that in your revision notes you can draw that diagram. Structure. Now, these, what I'm about to tell you, is mainly for Bradshaw models, and any points highlighted in orange usually is something that you could write that typically will give you a mark. So generally speaking, this is the structure that you should use when answering questions primarily associated with how something will change with distance downstream. Choose at least 10 sites along the river, and then you would go on about outlining how you collect the data with the various equipments. But also, if you repeat 3 times each site to get an average, and you write down the results on a recording sheet and repeat it 9 other sites downstream to see if there is a change. Really, if you write one of those 3 points highlighted in gold or orange on your screens, actually that is enough typically to give you a mark, as you'll see as we move through. So this was a common question that came up. This is a very nice question that came up in 2021. Describe a fieldwork method, test this hypothesis. You write a hypothesis and you talk about a fieldwork method. This question refers to how you could refer to the width and depth of the river, the velocity, sediment roundness, but you could also look at other factors as well, like gradient and things like that. So width and depth. To work out width and depth, you would need the following equipment: some ranging poles, a tape measure, a ruler, and a clipboard, pen, and recording sheet. So here we go. This is back to the question. What hypothesis could you write for width or depth? As distance downstream increases, the depth will increase, and likewise, as distance downstream increases, the width will increase. So how do we go about writing this? How do we get 4 marks to this question for the fieldwork method? So again, back to the structure. We're showing how something will change distance downstream. I'm going to write about how I should choose at least 10 sites, and then before talking about how I collect the data, then repeat 3 times, write down the results on a recording sheet, and repeat it 9 other sites. So how do I write my answer? Using that structure I talked about. Firstly, choose at least 10 sites along the river. Secondly, each site, 2 ranging poles are placed on both sides of the river, directly across from each other and kept in a vertical position. Thirdly, place a measuring tape between the ranging poles to measure the distance. It must be kept taut. Repeat 3 times each site to get an average. Write down each result on a recording sheet. Repeat at 9 other sites downstream to see if there is a change. So there's my answer for 4 marks. If you look at the mark scheme, choose at least 2 sites along the river. Yep, done. 1 student pole on each side of the bank. Yep, done. Place measuring tape. Kept taut, 1 mark. Directly across from each other. So you can see here my answer is very detailed, but I've got everything that I need to get 4 marks, if not more. Now, if I was writing this in a piece of coursework or had to draw a diagram, and this diagram I've got from the Field Studies Council, I would do something like this. So if you're doing this for coursework, you would need to, it's actually a great way to save word counts if you can provide an annotated diagram of how you collect the data. So again, you might want to use something like this, and you might want to try and write it a bit more concise just to help you summarize everything and to make it clearer and keep your word count down. So again, if you would like to use this and see how it works in a diagram, pause the video. So a method to measure channel depth. Firstly, choose at least 10 sites along the river. Secondly, each site, 2 ranging poles are placed on both sides of the river, directly across from each other, kept in the vertical position. And as you can see here, again, I've kind of included, it's very similar to width, but obviously now I'm measuring the depth. So if I go back to the mark scheme, you can see, again, I am ticking all of the boxes required for this mark scheme. And again, you can see recording the results, repeat at a second site downstream and calculate the average are very common things to include for river investigation. And again, this is what the type of diagram I would look like if I was drawing it for my coursework or if I had to draw a diagram. So again, thank you, Field Studies Council. Again, you can see here just to prove that the mark schemes are very similar. 2 questions from 2 different papers. If you look, again, I've included the questions here. And if I look at the mark schemes, again, my answers refer to, this is for width and depth, so I've combined them. But if you look at the mark scheme, again, very similar points between different years that need to be included. So please, these answers shown in the video should be enough, if you can remember what you need to write, to get you the marks. Okay, cross-sectional area. We said it's when you have to times the width of the river, by the average depth. So again, here the width of the river is 2.4, the average depth is 0.27. Then I got that by doing all that. Times the 2 together, 6.48, and again the mark scheme is there. So the width of perimeter, what is that? Well, is the entire length of the bed and the riverbank sides in contact with water. So it's not a straight line, it is the entire riverbed. To do that, you lay a chain or tape measure along the riverbed from one ranging pole to another, and the wetting perimeter should be much longer than the channel width. Again, I took this picture from past paper, and again, typically you might not be asked to describe a method, but if you did, you got the previous video. Very similar to width, but instead of doing a straight line, you just try and lay the measuring tape flat along the riverbeds. But you might be asked from a couple of difficulties or things like that. So again, here you've got the mark scheme to help you. Now for the next method that you have to be aware of is when you are measuring the velocity of the river, and there are two methods that you might be asked to describe, or you might have to suggest why the flow meter is more accurate than using a floating object. So the equipment that you need for measuring velocity are ranging poles, some tape measure, flow meter or a floating object, clipboard, pen, recording sheets, and a stopwatch. So these are the type of questions that you might be asked. Describe a fieldwork method to test this hypothesis, or describe two methods the students use to measure velocity. So that's 7 marks you've got there on the right hand side for knowing about the various methods. So how would you approach it? Well, if you're using a float, you would have some sort of diagram that looks like this. You would choose at least 10 sites along the river. And secondly, you would place 2 ranging poles 10 meters apart using a tape measure, one upstream and one downstream, and making sure they are in line with each other. So you can see that in the diagram. Next, you would place a floating object, and the floating object would be released using a stopwatch. The students will record the time it takes to go between the 2 ranging poles. And then the velocity is calculated by dividing the distance 10 meters by the time it took to give you meters per second. You would obviously repeat this at 3 times at each site to get an average, and then close to the left bank and then the right hand bank, again multiplying that by 3, and so the overall average is written down on the recording sheet. And then you'll repeat at 9 other sites downstream to see if there is a change. So that's how you would record velocity using a float. 2 ranging poles, 10 meters apart, time, record the time it takes for a float to go between the 2 poles. So if I was to show you my answer here, you can look at the 2 mark schemes I've got for you. And you can see that if you read the mark schemes from the 2 questions I showed you at the start, that actually our answer incorporates the best elements from each one. And so we have a nice answer that will easily get us 4 marks, if not more. Okay, the second method that we use, and perhaps the more accurate one, is a flow meter. And you can see the flow meter there. It's a propeller that you place within the water, and then you've got a digital display that tells you the velocity at that particular point. So again, like using a floating object, you would choose at least 10 sites along the river. At each site, you would place the flow meter into the center of the river, with the propeller facing upstream and making sure there are no obstacles in front of that propeller. And then after a minute, you would write down the velocity shown on the display. Or you might get given a graph that you have to sort of do a calculation for. You repeat at different points across the channel and calculate the average and write that average down on a recording sheet. And then you repeat at a variety of other sites downstream to see if there is a change. So unlike the floating object, this one is exactly the same. You have left-hand bank, center, right-hand bank, and you would be measuring the velocity using the propeller with the propeller facing upstream at those particular points. So nice and straightforward. Again here, if I was to place my answer, we look at the mark scheme on the left-hand side, and you can see again very similar points that need to be made at from each mark scheme. So my answer again incorporates the best of those mark schemes. So you should have an answer that, depending on what the question asks, will always get you the maximum marks. So again, I've never seen a question where you're asked to explain how you calculate the discharge. Describe the methods that you would go about with the discharge, but remember it's basically the cross-section area, width and depth, width times average depth, plus the velocity. If you had to do that, so you'd have to describe each of those 3 methods of collecting those data, but you might be given a formula here. So you can see the first part of this question is asking you to, shows you the formula to work out the cross-sectional area. So you can see here that you need to times the width and the average depth. So width of the river 3.45, average depth is 0.31 meters. Times those 2 together, you get 1.07 meters squared. So if you check out the mark scheme, there we go. Now, if you move on to the second part of this question, it explains how you would go about calculating the discharge. So they say here the discharge is calculated by the formula average velocity times cross-sectional area. And they've already done that for us, and they've given us some data. Now I'm going to go into how to answer this the question in a bit more detail in the data analysis part of this video, but I'll just quickly recap for you now. What is the correct conclusion to hypothesis 1? Well, hypothesis 1 is true. The discharge has increased with distance downstream as site 1 is lower than the discharge at site 3, and I've quoted some numbers for you there. And then you have to give one reason why river discharge changes downstream. Well, if the volume of water is increasing with distance downstream, any particular point and how fast that is travelling, therefore there must be more tributaries having added to the river, increasing the amount of water. Check the mark scheme. There we go. Another method that you're expected to know is how to calculate the gradient of the river. For that, you will need some ranging poles, a tape measure, obviously a clipboard recording sheet, and a clinometer. So these are some of the questions that they ask. Again, 4 marks. Describe how you would use the equipment shown in figure 2.3, here we go, to measure the angle of a slope. Or describe how the students measure the angle of the slope of the riverbed. So, remember back to this. These are the golden things that you need to include for a river investigation. So how would you write out the answer? So here's a diagram. I've got it for you. I'll put this on here just in case you want to use it for a piece of coursework. I would choose at least 10 sites along the river. In the centre of the river, I would place 2 ranging poles 10 metres apart, 1 upstream, 1 downstream in line with each other. One of the students would hold the kilometre next to the pole, that is downstream, and point at the same point on the pole that is upstream, and then the student would record that angle. I repeat this 3 times at each site to get an average, maybe on the left-hand bank, centre and right-hand bank, and then I would write down each result on my recording sheet, taking an average, and then I'll repeat this at 9 other sites downstream to see if there is a change. So, very straightforward, 2 ranging poles, 10 metres apart, 1 upstream, 1 downstream, in line with each other. The student chooses a point on the one that is downstream, with the kilometre, looks up to the same point on the ranging poles, that is upstream, releases the trigger of the clinometer and records the angle. Again, if I was to show you the mark schemes, and here is my answer, you can see again, really important that you need to have the equipment, and then you outline clearly how you place that equipment in the river and how you use it to ensure that every single time you are reliably collecting the angle of that slope or of the river channel. So let's move on to the next one. Sediment size and shape. For this, ranging poles, tape measure, clipboard, pen and recording sheet, calipers, and a scale of roundness. So how will I collect this data? Well, here's my diagram to show you. Again, very similar to average depth. I choose 10 sites, place my ranging poles, and then I would decide on a sampling technique. Now I could, within that river between the ranging poles, randomly pick up between 10 to 20 pebbles, or I could, as I measured the depth, I could pick up a pebble every 10th interval of that width. It's entirely up to you. And then once I've got that pebble, I would then compare it against a scale of roundness to see how to identify the shape, and that would write that down on my data collection sheet. Or to measure the length, I would use calipers and I would measure the longest part of that pebble. I write down all my results on a recording sheet to calculate the average, and then I repeat this at 9 other sites to see if there is a change with distance downstream. And here we go. If I compare it against the mark scheme here from that question before, you can see that, again, it's all about how you would go about using sampling techniques are really important here, how you would go about that. So this is the one that you need to mention, particularly sediment size and shape, but it's all about how you would go about recording that data, ensuring you've got the same measurement of roundness and length, and then recording those sheets and calculating an average. So in terms of measuring infiltration, I've only seen this question appear once since 2016. You can see a diagram of how you measure infiltration here, and you've got the question outlined before you. Now, sometimes when it comes to these papers of a very unique method or a method that is rarely asked or is unlikely that you've done, it might give you a little bit more information. So the second part of this question outlines exactly the length of time that you took. So it's really important that you read the whole paper first. So if you look at that, it says the students recorded the water level in the plastic tube every minute for 10 minutes. So that's information that you can include in the first part of this answer. So again, if I've got my golden rules and I look at the mark scheme, you can see here that I need to choose at least 10 sites that go away from the lake uphill, because that's what the hypothesis is exploring. At each site, I would insert the plastic tube into the ground, like you can see in the figure, so it is in a fixed place. I pour water into the tube until it is 120 meters. millimeters that you can see there, and using a stopwatch time a minute and then measure the water level in the tube. Do this for 10 minutes or until the water has infiltrated into the ground. So every minute you are recording the level of that tube. I repeat again at each site, and I record my results on a recording sheet. And this is the mark scheme. So again, pause the video, look at what you have to write, include that into your notes. Now the question moves on and shows how you calculate the infiltration rate, the time it takes, how fast water is infiltrating into the grounds. You've got the falling water level divided by time, and that gives you the answer. So you need to work out what that meant to show the calculations. So again, you've got the figure here, and we need to do this for site 2. So you've got what it was at 0 minutes, and then you've got what it was at 10 minutes. And for that, you need to work out the difference. So you've got 120 minus 48, which in this case is 72, and then 72 divided by 10 minutes. What you're telling me is every minute how much water is infiltrating into the ground. So that is 7.2 millimeters. Again, water at the start, water at the end. What the difference is, divide it by the time you measured infiltration rate for. Another method, again, I've only seen this once, is water pollution. And so here I've outlined the method that you would use based on the mark scheme and based on the information that was given to us in the figure, because unfortunately when I downloaded this from the Cambridge website, some information was missing about the method, so I had to use a different paper. Quality wasn't great, so here I've just outlined that method for you. So pause and add to your notes. And these are some other questions that they asked us to look at. Again, you had a Bartik index, and you had to do some basic questions there. So the first one was really easy. Which Bartik group contains the sow bug? So again, you had to find it, and it was 4. Here it explains to you how to go about collecting, calculating the Bartik index score. So you can see here it takes you through an example, and then here you just have to times the 2 together. So 3 by 4, 4 times 3, so on and so on and so on, to give you the answer of 27. 27 divided by 9. Please do find this exam paper online, download it, have a go through it, because it is very rare that you could be asked this, but just in case you can see it there and just review in your own time. To give you the 3, and if we check our answers here, you can see we are all correct. Quite a lot of work to do for 4 marks, but again, very standard 4 marks. If you carefully review the method, go through it logically, and you should be fine. So moving on to evaluation style questions. This is questions that really ask you to think about the reliability of the methods that you have used to collect data. Not every exam paper asks about the reliability for every single method. So again, I've had to use the ones that I just show you the ones that I've found questions for, but please do think about it. A lot of it is common sense. So when you're looking about the reliability or identifying weaknesses and difficulties, you're thinking about, have I collected enough data? Was it the right method? Did weather conditions influence what I did? Was there any human error involved in collecting this data? Were there obstacles in the river that might have affected me? Were there human changes or physical changes to the river that might have influenced the data? So for example, was there a waterfall in the way? Was there a landslide? Did humans build a bottling plant? All these type of things. So here are some questions, for example. Looking at using this method here for river velocity, explain why students may have produced unreliable results. So, could weather conditions influence this? No. Human error? Possibly. Did you, every single time, pick up the float as soon as it crossed the finish line? Were there obstacles in the river that might have affected the float? So again, some points here. Float could get stuck in obstacles along the way. Human error, that ensuring that the start and stop time is fair. Again, mark scheme gives you some extra points there. And then we look at the other questions about measuring the width of the river. If you want to make it more reliable, you would obviously take an average. You would make sure that the tape is taut every single time. So over 2 ways that the measurements were reliable. Again, some other points here for oxygen level, about how you can assume something like an oxygen digital meter for a flow meter or pollution levels is exactly the same every single time. So general points: is the data easy to collect? Were people working in groups? Were there enough sites selected within an area or along a transect? Was it on the same day? Was the average calculated? Does the method selected enable change to be shown? Was bias minimized? Was the equipment working? These are all various points that you could use to help you with suggest improvements or understand the reliability of the methods. And again, think about, would a digital display solve the issue? So if you're looking at a float or a flowmeter. One of the differences between the two methods are the fact that it's a digital display. There is no human error involved in reading that, you just have to write the numbers shown. As I said here, how you can improve the methods. So again, if you wanted to improve the reliability of the velocity and gradient measurements, here are some ideas. A pilot study is a really good one. You take more measurements, calculate an average, use a flow meter. So these are various things that you can consider. Again, pause the video, look at generic points that you could incorporate into your marks. So for example, a pilot study is one way that you can improve. You can calculate an average. You could do that for any method that you use. So again, really nice. Or you could repeat the investigation on different days, months, season to compare results. Those points there are really good generic points that you can apply to any investigation. So again, just to recap, points to improve the reliability, take measurements and calculate average, repeat at different times, months or years and compare, work in groups, collect more data and increase the number of sites. Is there an alternative way that you could use? Is there a digital alternative? And so these are the things that you need to consider when improving the reliability of your results. So data presentation questions, remember there are a huge range of techniques that they could use. Now I've made another video that talks you through the various different data presentation techniques that I've found that have applied to any past paper. So if you again look at that video, if you're unsure how to do a pie chart or a bar graph or a flow lines or iso lines, have a look at that video, it takes you through it. It might not necessarily be on rivers, it could be on any other investigation, but it's the technique of drawing those graphs that's really important that you can apply here. So please do look at that video if you are unsure when it comes to answering past questions. You can see the link on the video or in the chat, or please do just explore my channel. But I'm going to take you through a range, show you what you need to do, and really just re-emphasize this is down to practice, practice, practice. So some of the techniques that you could do: simple bar graphs, scatter graphs, pie charts, cross-sectional graphs. Again, scatter graphs showing various measurements. Again, a line graph to show gradients. There is so much variation within these questions that it's really hard for me to show you in this particular video. This video would be too long, hence the other one. But do not miss these questions. As you look at past questions, you can see they sneakily include these questions into the exam paper. So make sure you do not use them. Whenever you're drawing your graph, look at how the examples around where you need to draw have been shown and copy exactly what they've done, or go about thinking about how they've calculated that and drawn it before you draw yours. Use a pencil so you can always rub it out if you make a mistake, and do practice by looking at a whole range of past papers, not just for rivers, but in any topic, to get that practice of drawing graphs, understanding how they might use a slightly different technique each time, so you're just used to when you see this question, you know that in this paper I should get 12 marks out of 60 for completing graphs. So another chapter is when we look at data analysis. So you've shown the data has been presented to you, and you need to decide whether or not your hypothesis has been proven or disproved, true, false, or partially true. So again, I've looked at this question again very simply. You've got the data, you need to show if it's proven. So here, as I said to you before, that hypothesis 1 is true. River discharge does increase your distance downstream. This is shown because at site 1 it was 0.2 QMex, and it increased to 0.48 QMex at site 3. So this, you can essentially, this 2-mark answer sums up exactly what you need to do for these questions that are typically 4 marks. You state if the data collected is proven hypothesis, and you provide evidence to show that, as this mark scheme for 2 marks clearly shows. So again, here's some questions here for you. A whole variety of data. Again, you will see this as you go through exam papers and past papers, but there is a certain way that you answer these questions. You must, first of all, read the question carefully and just clearly have in your head, what is the hypothesis trying to prove? Does the question actually state for you if it's true or false? If it doesn't, look at the data. Does the data prove that the hypothesis is true, partially true, or false? And if it does, that's the first thing you write on any question, unless it's been stated for you that this hypothesis 1 is true. Hypothesis 2 is partially true. That is the first thing that you write. And then, because generally 9 times out of 10, this is always 1 mark. And then you find and write evidence to support your view. Do go and practice these questions using that structure. So if you look at the mark schemes, again, for these questions, you can see 1 mark certainly for stating if it's true or false, and then you get marks for showing that in evidence. So now it's over to you. Go online, find past questions for paper 4. This video really was general guidance for river investigations. Every past paper is slightly different, even if it's on rivers. So do, as you're answering questions on rivers, review this video, go use the chapters to wind forward or back to the various sections just to help you clear your mind. If not, look at your theory from paper 1, paper 2. Practice does make perfect with this question, using the mark scheme, incorporating the mark schemes into your notes. I hope I've shown you, I've given you mark schemes that enable you to write a very good answer for every single data collection method, which is pretty much perhaps the most unique information that you need for this particular exam paper. And do watch the other videos to find out more about the different investigations in more detail to help you approach this question. And if you really like this video, please do subscribe and share it. It just helps me know that exactly what I'm producing is helpful, and obviously I can upload, mend and change my videos if you feel they need to be improved, or I can respond to your comments for this video. Thank you ever so much.